Alright guys, so looking at those, what do we got for intercepts on that first?
X is 2, 0.
Okay, so 2, 0. And the y-intercept?
0, -2.
0, -2. Second one.
Wait, -1.
What?
It's -2.
Say it's 1 for both.
Oh.
It's just because it's 2 boxes.
Oh
but
my
it's
gosh.
Graphs
two
can be
bubbles left
deceiving,
out on the
right?
slide.
You gotta be able to zoom in or out appropriately to see that scale.
Graphs be deceiving.
Okay, so we have x-intercept at 1, y-intercept at -1.
Graphs be getting different too.
And no asymptotes on that first one.
Disappointing.
What about the second one? Okay, horizontal, y is equal to 0. Vertical,
X is equal to 2.
x is equal to 2. Do we have any intercepts?
No.
Not in that one.
Okay,
Oh, wait.
Not in that one.
okay. What's the y-intercept?
-1/2.
Oh my gosh.
-1/2?
Yeah.
Okay. What about this last one, vertical asymptote?
X is equal to -2.
X equals -2. Horizontal,
Y equals 0.
y equals 0. Y-intercept.
+1/2.
So 0, +1/2. Okay. So we've got some pieces of information here for 3 individual functions. What we're going to do is try to combine some of these functions and see what stays, see what doesn't stay. So I'm going to take these first 2 functions, f and g, and I want to divide those.
Oh, nasty.
Or actually not divide, I'm going to multiply. Okay, I'm going to multiply f times g. What do I get if I multiply f times g?
X minus 1
X minus 1.
multiplied by 1 over x minus 2.
Can I just put that in the denominator?
Yeah.
Since the x plus 1 multiply, or x minus 1 times the 1 will just be x minus 1. Okay, go ahead and graph that, and let's see what of these pieces of the graph actually stick around. Okay, intercepts, asymptotes. What stays the same?
Vertical asymptote.
Okay, you said vertical is the same?
Yeah.
So vertical asymptote would be x is equal to 2. What about horizontal?
Got shifted up 1.
Okay, so y is equal to 1. Intercepts?
Shifted up. Wait. Oh yeah. 1.
What about intercepts? Which one?
Y-intercept is at 0 and 1/2.
Okay, so y-intercept 0, 1/2.
X intercept is 1, 0.
Still at 1, 0. Okay, so if we look at that, what stayed the same? Okay, so vertical asymptote stayed the same. What else stayed the same?
Y-intercept.
No, it was the X intercept.
Oh, I was thinking.
This one we had a negative 1/2 for the y-intercept, so that one didn't stay. But the x-intercept did stay intact.
That's it.
Okay, so those 2 things stayed consistent. All right, let's try 2 different functions. Let's do f and h. Okay, f times h of x. Well, let's look at that graph.
So it's just going to be X minus 1 over X plus 2.
Okay, so basically the same function. That numerator stays the same, denominator gets slid over underneath it. So let's see what we get for intercepts and asymptotes.
The Y intercept is the same.
So what did we get for that? You said y-intercept was the same?
Wait a second. Wait a second. I didn't
H.
give me one.
H.
So what do we get?
Y-intercept is not the same.
X-intercept is the same.
Yeah, that's what I meant to say.
So x-intercept is still at 1.
Yeah.
Y-intercept?
Negative 1/2.
Okay, so negative 1/2.
Vertical asymptote's -2.
Vertical asymptote, x equals -2. And horizontal,
Y equals 1.
y is equal to 1. Okay, so that meant vertical stayed the same. And x-intercept stayed the same?
Yeah.
Okay, but the y-intercept it ended up being one or the other, right? It didn't necessarily, no, I'm looking at the wrong one. It was opposite again. Okay, so both of these, though, the x-intercept, the vertical asymptote, stayed exactly what they were to start with. All right, let's try a triple. Let's do f times g times h of x. What's our function going to be if we do that?
Well, the x minus 1 will be on top.
X minus 1 still on the top of the fraction.
And then it's going to be in parentheses on the bottom, x minus 2, and x plus 2.
Okay?
Is that right?
Mhm.
Okay.
Yeah. So we just take both of those factors, the x minus 2, x plus 2,
It's the whack one.
and they become the two factors in the denominator. What do we expect to stay the same?
The x-intercept.
The asymptote.
Okay, so
Vertical
x-intercept
asymptotes.
And the
will be at 1, 0.
vertical.
And you're saying vertical asymptotes would be at
X plus 2.
2 and negative 2?
Yeah.
Okay, I would expect the same. Let's graph it and see what we get, if you haven't already.
I didn't.
The funky one that can like go through
The middle
the
part.
horizontal
It's
asymptote.
kind of rude.
So for those that have graphed, are these correct?
Yeah.
Yeah, if you put that into Desmos, you're going to get those same two things staying consistent. Okay, which is nice. We have some consistency within these graphs of things that we know. So what about the y-intercept and the horizontal?
Y-intercept is at 4?
You said 1/4?
Yeah, I think so. Is that right? Yeah.
Positive or negative?
Positive.
Okay. And horizontal?
0? No. 0? Yeah. Well, yeah, because
Yep.
it can go through it.
Yeah, it can go through it. So eventually on the outsides, is it approaching? The answer is yes on this. Okay, so do we start to see some other connections though?
Yes.
What are they?
Explain the x-intercept and the vertical asymptote stay the same.
Okay, so x-intercept and vertical asymptotes stay the same. What about if I look at the y-intercepts?
They're multiplied together and by 1.
Okay, but think about what the y-intercept was initially. Y-intercept was -1, 1/2, -1/2. Do those multiply to give us our new y-intercept?
Oh.
Yeah, it does. Okay? Now, I'm not necessarily going to go through piece by piece and find those individual y-intercepts, but there's a relationship between those, and it's not coincidence. But I do want to see that my x-intercept stays consistent and my vertical asymptote stays consistent between these graphs. So let's try to put this onto a graph and see what it looks like. By hand, not just what you are doing on Desmos.
Desmo.
Okay? So if I know that I've got vertical asymptotes at 2 and -2, I'm going to go right 2 and left 2, put my vertical asymptotes. I also know that I had an x-intercept at +1. Now, how would I find that just looking at this function? Either of those, really.
Okay.
Okay? How would I find vertical asymptotes just looking at that function?
It's the x. Well, the x is the bottom part.
Okay, so the denominator equals 0. So I've got 2 and -2, that would be the two zeros of my denominator. And that's going to tell me where my vertical asymptotes are. Well, where did I find the 1 for the x-intercept? I found that up in the numerator. Okay, so if I have this in fully factored form, it tells me a lot of good information about this rational function. Okay, well, how do I find this 1/4? Without just staring at the graph that you had, how do I find a y-intercept?
All the y-intercepts multiplied together.
Okay, so if I knew all the y-intercepts of each factors, I could get it. How else? Set what to 0? Okay, I set that x equal to 0 and plug it in. So if I find this as 0 minus 1 divided by 0 minus 2 times 0 plus 2, is that 1/4? Yeah, it is. That's a -1 divided by -2 times 2. That gives you a positive 1/4. Okay, well, how would I know that the horizontal asymptote is y equals 0? Just looking at the function.
Because the x powers are the same
Not the same.
Not the same. No, wait, the bottom has more.
Okay, because the degree of the numerator is what? So x to the first, and the denominator, x squared. What happened when it was larger in the denominator? 0. Okay, so this is 1 over x if I were to divide that out, but that is going to approach 0, because as x gets really big, this fraction is going to get really small. Okay, so that's where that y equals 0 comes in. Yes?
So with the x squared, is that just because you're like multiplying the two?
This x squared?
Yeah.
Yes, because I have an x here multiplied by that. So if I were to distribute that out, I would have an x squared. Okay, and there's going to be other terms after that as well, but we're looking at those dominant terms like we did last time in class. Okay, so I know y-intercept is at 1/4, so I'm going to plot that on there. And I have the horizontal asymptote at y equals 0, so I'm going to plot that on there. So now we have some boundaries. We have an idea of what's happening to this graph. Okay? I know I can't hit -2 for x, I can't hit +2 for x, and eventually, horizontally, I'm going to flatten out next to that x-axis. Well, what else is happening? How in the world am I going to figure that out?
Well, it's just like everyone knows like this.
But how do I know whether it's here, 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 here?
Negative and positive.
Unfortunately, some of those rules aren't going to work anymore.
Well, that friggin' sucks.
Okay? Sometimes it's going to end up down here, sometimes it's going to end up here. Even if it's positive.
Wait, so do you just put numbers in on the graph? Like, could you put
So
like
what
-5
numbers?
or something?
I think that's a great choice.
Oh,
I might even go a little bit closer to the asymptote, just so it doesn't get as big.
okay.
So maybe a -3. Okay, so let's choose some values. -3 is on that left side of the asymptote. Great choice. What else?
0.
Okay, and we kind of already have 0, but I can put it on here because that would be a good choice.
3.
Okay, +3 would be a good choice. I would.
-1.
Just 1. Are you looking for 1?
I would say we don't need the -1, but you could use it.
2. What are you looking for? You're looking for
Okay, what about 1.5?
Okay.
Why would I care about 1.5?
Because you want to know which direction my pin is going.
I want to know, is it going up or down off of that intercept, for sure.
So I was trying to
Okay, why don't I care about -1? It would work, but why don't I care? I already have the 0. It's already telling me I'm going up on that left side.
Well, that would be weird. It was like, I don't know.
Okay, because I've got that intercept at 1, and this point is higher, so I've got to be going up. Now, question for you guys though, what tells me I can't come back down? Not the asymptote there. If it was on the outside, maybe.
Can it only cross it once?
Why?
I don't know. I just was asking.
No, it's a good question, but why? Specifically, why in this case can we only cross at that point?
That's
That's the only.
That's our x-intercept. Okay? We only had one intercept. So I can only cross the x-axis one time. And if that asymptote happens to be on the x-axis, that's the only time it's going to cross. Okay?
okay, so let's say we don't have an x-intercept. Could you just have like one that just goes like that?
Where it just, instead of crossing, it just turns around? Absolutely. And we'll talk about how we determine that.
Okay.
So based on what we have, though, this piece right here, I know is going to go up on that left side and approach that asymptote, that vertical asymptote. Because we will never, ever, ever cross that vertical asymptote. Why?
You just keep getting closer to 0.
It's the law.
It's the law.
That's just how
Why is it the law? Why is -2?
Because we put 0 in the
It makes it not function.
It makes it undefined there. Okay? I can't get a value at -2. I guess it'd be this right here. Because it's undefined. Okay? I can make my y's equal to 0 in this case because I had an x-intercept, and that's okay. But I never can make those 0 in the denominator. I can't divide by 0. Alright, so what else? What are my other y values here? Someone plug each of those in. Let's figure out what we get. You guys can use calculators too, that's fine.
figure it out.
Wait, what are we doing now?
Plugging the x's in to get the y's.
For 3, it'd be 2/5.
Positive 3?
Yeah.
Are you
Yeah,
sure?
but they have a number.
Okay.
That's what I got too.
2/5? We agree with that?
Nine.
Okay, what about the others?
1.5, I got -2/7.
Negative 2 over 7? Okay. And what about the negative 3? Negative 4 over 5? Okay, so what does that tell us, though?
Which direction the things are going.
Okay, so where's the coordinate negative 3, negative 4/5?
And the
Quadrant.
left bottom one. Yep.
So left 3 and down a little bit.
Yeah, there you go.
Okay, so it's going to be approximately right there.
So that tells you that it goes like that.
Okay, so on this right side, I'm going to drop and get really close to that vertical asymptote, but I'm not going to bend back. It's just going to get closer and closer to that asymptote. On this left side, it's going to raise up and get closer to that asymptote as well. But why are we not crossing?
Because it'll be undefined.
Because I don't have any more intercepts. Okay, I only had one x-intercept, and that asymptote is right on the x-axis. I can't cross it again. Okay, well what about here, between the intercept and the asymptote? Am I going up? Am I going down? How do I know?
Down.
Down because the y is -2/7.
Okay, at 1.5, I'm down 2/7. So that piece is going down and approaching that vertical asymptote. And then over at 3, I'm up at 2/5, which is about right there. What's happening there?
It's going
Okay, basically a reflection of this. So on this left side, I'm going to raise up and nearly go vertical next to that asymptote. On the right side, it's going to nearly flatten out against that horizontal asymptote. That would be our graph of that rational function.
Heck yeah.
Ooh, not bad.
That was pretty.
Questions
radical.
on that one?